Joining me in the studio is space journalist and astrophysicist Sarah Cruddas. Thank you very much for coming in to speak to us. So this is a very exciting mission. Just tell us more about, well, why do we need to know about asteroids? Why is this important?
Well, asteroids are basically the frontier of the solar system. They were around when everything formed. They're 4.5 billion years old, and they haven't really changed much since the Earth and everything else came into formation. So this mission is really about two fundamental things. It's about our origin and it's about our destiny, because scientists believe that the water which came to Earth actually came from an asteroid, and the building blocks of life, such as amino acids and sugars, came from an asteroid as well, colliding with a very young Earth in our solar system. And we also know on the destiny side of things that it was an asteroid colliding with the Earth which actually wiped out the dinosaurs. So we need to know, will we go down that same path again? Because there's also a very slim chance, a 1 in 1,800 chance, that this asteroid could actually collide with Earth in the year 2086, and an even higher chance next century. So there's two primary reasons for this mission, but it's hugely exciting to actually go to an asteroid, to orbit around the sun, get a slingshot around the Earth to get the energy, to then ride alongside this asteroid, travelling at more than 60,000 miles an hour, go down to the surface of the asteroid, grab a sample, suck it up like a giant vacuum cleaner, as you saw on that video, and then bring it back to Earth, all within the space of 7 years. It's really at the forefront of science and technology.
OK, so you've laid it out. You've laid it all out very nicely. And in terms of the aims of this mission, you say it's about the past and it's also about the future, because asteroids, you say, asteroids are the reason humans exist, but then also about the future because there is a chance that an asteroid could collide with the Earth in the year 2080, but is there any guarantee? How much more are we likely to learn about the risk of that when
the thing is, we don't know much
back?
about the movements of asteroids, and this is down to something called the Yarkovsky effect, and this was discovered a long time ago by a Russian scientist. And basically, the heat from the sun actually heats up one side of the asteroid, and it changes its orbit. So Earth is a much bigger object in space. It's very steady. This asteroid, Bennu, that we're going to, is only around 500 metres in diameter, so it's much smaller. It's harder to predict exactly where it will be, and it comes very close to Earth. So we want to be able to map the asteroid, and for the very worst-case scenario, and it sounds like something out of science fiction, know whether in the future we could send a mission to actually move it. So hugely interesting for scientists. And then in terms of the origin... Oh, sorry.
No, I was just going to ask you, just out of curiosity, in a scenario like that, as distant a prospect as it might be, can one avoid being this collision?
Well, we don't know yet. That's why we're going to an asteroid. But in terms of the origin side of things, I mean, asteroids hold the key. They were around at the beginning of the solar system, and they're hugely exciting to scientists. I mean, this is part of a new generation of space missions. I think we take for granted how much we know in space exploration, but actually we're only just starting to scratch the surface.
And briefly, Sarah, this mission is also significant for commercial reasons.
Well, a lot of companies, we're in a new era in space exploration where private companies are actually going in. It's not just about governments. We're seeing private companies going in and seeing if we can make money. So part of the mission is to look at resources. What resources are there on asteroids? Asteroids are potentially a great source of minerals, but also for water. And water's important, not because we need it to live, but because it's the key ingredients for rocket fuel. And you could see a future where asteroids, and potentially even the moon, are intergalactic petrol stations, to put it in layman's terms, which allow us to explore further into space. So scientists are very excited to know more about what is on this asteroid.
Well, thank you very much, Sarah Cruddas, for explaining all of that very clearly for us. It's definitely going to be a fascinating series of missions.
Thank you.